Good afternoon, everybody. Thank you so much for joining us after our annual drama at TechNet Cyber. I'm George Seifers, Editor-in-Chief of Signal Magazine, and our next speaker in the Signal Innovation Showcase series is Peter Briscoe, VP and Head of Sales for Blue Planet at Ciena. He's going to talk to us about Ciena's Blue Planet solution and how it uses AI to help provide a network common operating picture. So, Peter?
Thank you, George. Thank you, George. So I think I've been helping customers over 30 years try and automate their operational environment, taking software and making sure that they are delivering change within their network as efficiently as possible for different areas. And today I want to talk about how Blue Planet can help do that through this unified operational view. Just a little bit, if you don't know who Blue Planet is, because it's a somewhat unique group, we're a software arm within Ciena. We're wholly owned by Ciena. Ciena is one of the major sponsors here. It's a technology vendor that is being used across the industries. But we focus on multi-vendor software solutions, helping our customers automate all of their aspects of the operational environment. And so we've built this company segment up, this division up over the last 8 years. We've grown to over 700 professionals, focused purely on operational support systems. It's not open software systems, it's operational support systems. We have a number of customers globally, so over 200, some of the big tier ones in North America, also government and other areas. And then we've been recognized quite openly for our innovations that we've brought within the product space as well. So now you know a little bit more about us, what's driving some of the conversations that we're having with our customers. And it's all around complexity and demand. And the latest lot of complexity and demand is AI. And if I didn't have AI up here, I think no one would actually listen to what I'm saying. So you've got to have AI as leads the topic. I'll put it up early, and then we'll see if we come back to it later. You can have a bingo card for how many times I say it. So just the driving change in patterns of use of networks to support AI-type services is really a challenge for a lot of our customers. There's a lot more data center interconnectivity required. The amount of volume of interconnect data capacity required, we see increasing sixfold between now and the next 5 years. And that's just going to keep going. There's also studies that are showing how the actual amount of AI-enabled data or AI-impacted data is also expanding significantly. That has a different traffic pattern than most other systems. So not like video when you're streaming it and pushing it out, you're actually collecting it all up, bringing it to data centers, processing it, and then pushing it back out. So it has a slightly different dynamic. So that complexity on top of all of the other complexity that operators are dealing with across virtual, physical connections, all of the different ways in which they have to operate, is just adding further burden. And so we see probably 3 key challenges that our customers are going through in managing this. The biggest one is information fragmentation. So having the systems that they need and the information about those networks spread broadly across both different databases, spreadsheets, someone's laptop, someone's machine potentially under a desk, not being brought together. So it's very difficult to be able to generate a holistic view of everything that needs to be managed and operated on. So that's one of the biggest areas, is pulling all that data together, having as a common reference to be able to drive change. Second one is the level of manual automation. There's a lot of manual processes still within our industry touching the network. It's not unreasonable to have over half a dozen people touching a request to make a change to the network. Every time it's handing off to another person, you're introducing another potential error, another delay, another point of contact which could get wrong and make an issue. So removing a lot of those manual touch points is really important. And then the third one, which is partly linked to the other two, is inconsistent configuration of the network. If every time you deliver the network, you're doing it by hand slightly differently, that has a number of different fallouts. And that might be because you've acquired companies or you've merged groups and organizations, and one part of the country does it different from another part. But if every customer site is slightly different, you can't do bulk changes, you can't manage those changes, and it automatically allows you to sort of inhibit the amount of automation you can bring. It can also introduce security holes. So you're not being consistent in how you're configuring your devices, you're opening up those devices to possible threats and possible challenges. So with those three backgrounds, what does Blue Planet do to try and help you address those and some of the other opportunities? I'm not going to read it in this very tiny text at the bottom, which you can't obviously read. That's just for me. So there are really three functions that we have. We have an inventory capability. That brings all of this information together to a single federated view. So we can pull all of your disparate databases, all of your disparate data sources, and then we can reconcile it with the live network through discovery. So that allows us to increase the quality of the information that we're using. Incorrect information or low quality information just means you automate and fail faster. You do not actually get it right first time. Getting it right first time is the most important part. So the second part of it is orchestration. We have a model-driven orchestration platform that allows you to manage what we would call intent-based orchestration. So it allows you to describe what is it that I want to actually achieve in a very abstract form, a particular bandwidth connectivity with properties between two locations, and convert that into the configuration which is specific to either a vendor or a technology across a wide set of network. So that automated process uses the information base, then drives that into the network in a very efficient manner with as little manual intervention as possible. And then finally, we gather all the events that come out of the network, combine what are traditionally three separate platforms, fault, performance, and SLA management, into a single platform. In doing that, we can get a holistic view of all of the events across the network and apply machine learning and AI, second use, to that data to be able to understand what is it that's actually happening. What is the root cause behind the actual issue that you're seeing? Is it this particular network technology layer, or is it really the layer below that's supporting it? So instead of spinning up multiple teams, you actually focus on the true problem. So now you have a bit of an understanding of what the problem is, what we do. I want to just introduce three customer use cases to explain and give examples of how we've helped our customers in providing a unified view. So that first one is actually a use case in the UK. So this is a security act that the UK put in place that required all of the operators to report a very accurate information, an inventory or a database of all of the equipment they have in their network, what version, exactly where it is, and how is it being used. They collate that across all of the different vendors in that network so they can understand if they have an infrastructural challenge or threat within their backbone of their country network. So they had to provide this report in a very timely manner. So they had a deadline of 12 months to generate it. We had to pull information from 15 different sources, bring that all together into a single view, reconcile that to the network across multiple vendors, not just our own Ciena equipment, in this case actually across a lot of other vendors, not our own equipment vendors, and provide that out to the government on time. And we were doing that incrementally over the 12 months. We were able to hit that target, which means they don't get a fine, which they're happy about, so they don't want to be fined for things. But also they had an accurate now foundation to be able to plan network changes that they were moving on going forward. It was a very timely approach, and it then allowed them to drive the level of automation to the next stage. Second use case, much bigger operator here in North America. I'm not going to name it on the stage, but they have over 1,000 users in their environment. So they had some automation. They had pockets of systems. What they were doing, though, was swivel chairing between each of these systems. So they'd do some automation in one. They would then hand copy the result of that, put it into another system, run some automation, hand copy the outcome of that into another system. Every time doing that swivel chair, they were potentially having errors. Even if they were cutting and pasting, there was delays in that process, and they were having significant delay in getting new services out. And they were really struggling. Their existing platforms couldn't support new services like SD-WAN. Some of the flex grid, or what we call WaveLogic type technologies, weren't supported by these platforms. So we brought all of the information together, provided a single operational environment for them to work in, and then automated that swivel chair out of the system. So there was no indication of anybody manually having to move data through each of these different stages. We're able to monitor it. Now, because they knew how much effort and time it took to do that swivel chair, they created their own dashboard internally to work out every time we put a transaction through and we avoided all of that swivel chair, how much time did we get rid of? And they put a figure on that. That was over $1 million a week that they were saving in operational benefits, which is a significant major change. Now, they've got 1,000 people, big organization, so a lot of change, but that's a significant benefit and a very fast return on investment. Not just were they removing the operational cost, they were able to accelerate their delivery of new services. It's 80% faster. They also had a single reference that they could use to understand what was going wrong. They could resolve problems 90% faster than they could before, where they had to go into all of these different databases and cross-correlate what was going on. So a significant change, a massive operational environment, and just one of the examples we have. And the third one, which I'll look at, is very specific to a government case where they had over 600 tickets a week, most of them on Destiny, source, IP flows. And they had no way of understanding what had happened historically. So they could go and look at the network and work out where all the IP flows were at this current time. If they had a particular issue being reported, they could look at that. But most of the times, there would be some issue back on Tuesday where a connection between, say, Denver and Chicago tromboned via New York and no one knew why. And it meant that the service dropped all of the parameters, it broke all the SLAs. We have an ability to capture all of that routing traffic in real time, record it sequentially, and allow you to go back exactly to the point in which you had an issue and understand, well, what was happening? Was a route being incorrectly advertised at one part of the network? Was it being managed incorrectly? Was a configuration change that caused this particular issue? So they were able to do that. They were taking 45 minutes when they had the data to solve the problem. Using this, they could then easily identify what the problem was, compress down that time to under 4 minutes. So a 10 times reduction in what they were doing. And also, then this acts as a digital twin. Another great buzzword if you're out there. Digital twins for us, it allows us to model the behavior of this network. So if you take out that core network in the middle, one of those routers, we can then understand where does all the traffic go? Do you have enough bandwidth in this network to survive a reduction of a particular link? We can then understand, is there a service window we want to have that minimizes the impact to customer services? So using that is another way of being able to predict the behavior of the network. Again, saving them significant amount of problems, also reducing the chances of having an SLA breach. And then that planned maintenance window is a really significant benefit for them. So those are the three main areas that we've been looking at. If we talk about common operational view, what is it that we bring? Biggest one is data accuracy. Most of the customers we go to, their data accuracy is at best 50% correct. So they have data, they might have more data than they know what to do with, but most of it is incorrect. So getting it into one place is only really the first part. Getting the accuracy of the data up to a point which actually makes a lot more value is really the big important part. So being able to federate directly to the network, compare the network view with the offline view, reconcile those differences in an automated fashion is a significant amount of value, as we said. You don't want to fail fast, you want to get it right first time. So getting people's quality of their inventory over that 95, 98% is something that we do, and we do on a regular basis. The other one is speed to delivery of new service or speed of network change. So most customers want to be able to deliver a request as instantly as possible. A lot of the times that's measured in weeks, sometimes in days. We're looking to compress that down into hours and minutes as much as we possibly can. Taking out all of the very time-consuming issues, being able to build a set of rules and deliver that consistently across the network. So when you need to, you can upgrade and do that in a single approach as well, a single step. And then finally, mean time to repair. So being able to take the time when you have a problem and then get the network back to full operational business, getting that compressed down so it's as small as possible. That's typically where we see multiple teams being spun up. One for the IP network, one for the optical network, one for the transport network. And all of the different coordination means you're wasting an inordinate amount of effort, but also a lot of time. So compressing that down, we see at least a 10 times reduction in the mean time to repair for networks where we have a good automation platform in place. So, in summary, Blue Planet, what does it do? It federates the data into a single source, gives you a single pane of glass. You can then use that to enable a very efficient automated delivery method that allows you to get services to customers as quickly as possible. It understands not only what the network is today, but what the plan of the network is in the future. So you can use that to critically add capacity as you need to, in the right place at the right time. You don't overbuild a network in the wrong place. You make sure you get the network capacity to meet demand as efficiently as possible. And then finally, we use our platform to ensure the network quality of the service you deliver is maintained and stable. So monitoring all the events, ensuring that that manages it and meets the SLAs that you've guaranteed to your end customer. So thank you very much for your time. I know we've come to the end of this. If you want to hear more, not just from myself, but my colleague Matt, you can wave Matt. There you go. We'll be on booth 2711, just down the road, big red banner, Ciena. It'd be lovely to answer your questions. If you have questions now, more than happy to take them up after this session. Thank you again. Okay.
Peter, thank you so much for a great presentation, and thank you all for joining us. Our next session will be at 2:50.